because of this in Sunday. They're saying that they do not have cards, blah, blah, blah. So I'm just waiting for them.
Okay. Annie, welcome. Welcome, welcome. Sharon, good afternoon. Thanks for joining. Akani, I'm not sure if this has to do with your network, but I admit you, and then it just says that meeting, and then it doesn't come through. Okay, cool. There we go. Okay, Nelly.
Good afternoon, Gideon.
Hi, Clinton. Clinton, I know you're busy. I wanted to just add you so that when I end, you would have the recordings, because there's a few sessions on the ERP that is missing on YouTube that I might need you to help download and upload there, because the guys keep asking.
Gideon, what session are you guys at now? Session 3 or 4?
We are on session 4. We are behind by one module. So
I believe on YouTube I've recently uploaded, which is today, session 3.
okay, all right, cool. But I'm talking about the ERP group.
Yes,
Remember,
ERP, I got
finished,
module 1, 2, and 3.
but there's only module 1 and 2 on YouTube.
I uploaded 3 today.
Okay, cool. And I've just finished 4 now, so at least we're on time on that.
I'll get it. I'll get that from Sharon, and I'll upload it within the course of today.
All right, thanks, Clinton. If you want to jump off, you're welcome to, or you can just sit behind as well, so that when this is done, you get the recordings, and then you can, yeah.
No problem, Gideon. So I'm currently on another call. I will go on mute and I will sit in the session.
Cool. Thanks, Clinton. Okay, guys. I think we can just start, and the rest of the guys will catch up as we go. In this module, I think we're going to actually start looking at something exciting from this module. All the previous modules that we've looked at have always been something cool, but if you want to really build a a robust application, we're going to start looking at how to do that in module 4 going forward. Can someone remind us what we did in our last session? I just want to make sure that you guys have been paying attention and you've been in class wholeheartedly. Anyone? You can just unmute if you. No one? Mamonashi? Noleleli? Akari? Mashapa? Tuliswa?
We did Azure Blob Storage, and we also did the management of the Azure Blob Storage lifecycle, and then the work with Azure Blob Storage as well.
All right, cool, awesome. Okay, So I'm going to share my screen and I'm going to start. I think what I'll do is for module 4, I am going to just go through the slides. And if we have enough time after we've gone through the slide, because we are behind technically, I'm going to look for one of the modules as we go forward or just add an extra day. So I have done some recordings of the videos for the catch-up for Azure functions, for durable functions, which is the one piece that we're missing. And I've also recorded all the labs in that module as well. Problem is, after the recording, I wanted it to be crystal clear, and I recorded at 1080p. So after producing, I ended up with like 400 megs of the video. So I'm just looking for a way. If it doesn't work out, I'll probably just have to record it at 720p, because that's just way too big. It's very hard to get that on YouTube. It's not impossible, but it's quite hard to get it on YouTube. So but sometimes this week I have 3 videos already. I'll find a way to upload them to where you guys can actually use it as well. Okay, cool. So about a decade ago, if you were building applications, one of the choices that you have to make for your application is a database where your application data is going to be stored in. And there wasn't a lot of choices. Technically, there was just like one choice, mostly, which is relational management or relational databases. And relational databases, the concepts that allows us to be able to create database, create tables, relate the tables together, and query the tables whenever we need data from there as well. So for some of you who have some familiarity with relational databases, it works quite well for enterprise application. However, in recent years, there has been a lot of changes to the nature of data and how we use it. Data is larger than before. There's more vastity to data than before, and there's more velocity to data than before as well. So what I mean by that is that in the past, whenever we're building application, we usually have to worry about the application domain. So if you're building like an e-commerce application, you would have to worry about creating a data structure or a table structure for things like products, which is where you're going to store your information. Things like customers, things like orders, things like, and so on and so forth. And we would relate these tables together. I mean, the way we would do the relationship, for example, is if you have a relationship between a customer or a salesperson and a customer, you would know one salesperson can have one or more customers. So if we have a salesperson table, for example, and they have a first name, and they have a last name, and they have age, and they have a gender, and also the one thing very synonymous to a relational database is that you always have to have some kind of unique ID for that particular table. So in this case, you could use pretty much anything. So you would have a salesperson name called Gideon Ogongo, and maybe the age would be 20, and then the gender will be male. You would also have a salesperson name called Sarah Jones. Maybe she's 30, and then you would have a salesperson called John Doe, and John Doe will probably be 40, and it's a male. And if you were creating a relational, if you were doing this in an RDBMS or relational database like Microsoft SQL, MySQL, Oracle, you know that this would be stored in its own table by itself. So this would be a table on its own. And then if you have a customer and you manage customer ID, and you manage customer name, and you manage streets, city, state for the customer, and then maybe any kind of credit that the customer has. To relate these two tables together, you know that you have to define the type of relationship first of all, which is a one-to-many. And here, this will be the one table because one salesperson can have one or many customers. So in that case, the way you would do the relationship is that you would add an extra column in the customer table for the salesperson. So you would say salesperson ID. So for example, if you have a customer 100, and this customer is owned by salesperson ID 1, and the name of the customer is MS, and they are on MS Way in Johannesburg, and then in Gauteng, right? And then if you have another customer 200, and customer 200 is also owned by this person, and then ITT Way, and they are also in Joburg, Gauteng. And a customer 300 maybe is owned by salesperson 2, for example. And maybe this is ABC Corp, and they are on Main Street in JHB, or let's say in Pretoria, for example, and also in Gauteng. So this is what a traditional relational management system would technically look like, and we write what is called transact SQL to be able to see the content of this table as well. So if I want to see, what is inside, if I want to see what is inside the salesperson table, I could write a query such as select star from salesperson. All right, and if I run this query against the salesperson table, I'll be guaranteed to see all the records that are in the salesperson table. I will be able to also perform things like a filter, like where last name equal to Ogongo, like so. Okay, and you can say where an age is greater than 30 or age is greater than 10. It would automatically filter out where the last name is equal to Ogongo and the age is greater than 10 as well. And then if you want to write, you can do the exact same thing for customers. So you can say select star from customers, where you can basically want to see all the customers that are in Gauteng. So you can say in Gauteng, and whatever else information you want to put there as well. And occasionally you want to show first name from the salesperson, you want to show name from customer, you want to show province from customer, and then you would say from salesperson something along this line, and then you do some type of inner join on customers. Okay, and the way that you would do this is you would represent salesperson as S and customer as C, and then obviously you would preface the column from where it's coming from as the first name, and then C.customer, and then also C.province, and then you would do a where clause where S.unique, which is there, equal to, you would basically be retrieving salesperson that have a customer if you compare the customer the salesperson ID. So this will be C.sales PID. And this would retrieve all salespeople that have a particular customer, because when the sales ID matches the unique ID here, it will essentially be showing that particular salesperson ID as well. So this is how, for the longest time, a relational management system works. But relational management system has its own challenges. Obviously, if you have hundreds and hundreds of tables, you know, when you are writing query to combine the content of this table and retrieve them, you would experience a tremendous amount of performance degradation. And also, when you are saving data from an application, you also have to break it down into the respective pieces as well. So it seems very unnecessary that, you know, you have to sort of like break the data down all the time, and then whenever you need it, you would also have to pull it out as well. So about a decade ago, a new type of database that is surfacing, you know, lots of people started thinking of ways to improve on data storage, especially for application. More real-time application was becoming popular. Applications started having data with characteristics like high varsity, high velocity. You know, if you are a company and you have a global sales people base, and some salespeople will have first name, last name, and some would have something else. And to try and create a schema in a table to accommodate for this would probably be a challenge. This probably doesn't apply to, you know, things like this very small application such as this one. But the point that I'm trying to make is that it became apparent that the relational management system wasn't really going to cut it for very, very high varsity data, high velocity, and also a very large amount of data as well because of the performance issue that you experience. So because of that, lots of options started coming up. And I guess before, what is it called? Before a relational management system, a lot of people use a concept called XML. XML was also some kind of data storage. I'm just going to show you what an XML document looks like. So I'll create a new empty web project. And then I'll just add an XML file in there, and I'll show you the two types of XML that is required. Now, I think this is super important. I'm just trying to cover the bases, especially before we go into Cosmos DB. I think it will make a lot of sense after you've seen this. So I can create an XML file. I can call it customers info. All right. And XML was slightly different from a relational database because it used a single file to sort of represent, you know, the type of document that you want to store. And there were just a few things about XML that also didn't cut it as well. First of all, XML has this header that sort of increased the payload for the XML documents, something we don't really have to get into that. This is not a course about XML, but there were two types of XML. So there was element-based XML, like so, and there were also attributes-based XML. Both were sufficient enough in representing data structure. So to give you an example of an element-based XML, I would say we would use the same salesperson like so. So XML always has like an opening and a closing tag. And how you represent a closing tag was with a / of the same element. So this was called an element. So every opening element must have a closing element, as you can see there with the / salesperson here represents the element as well. And this salesperson obviously would have a first name like so, and inside here, the first name will be here, and then they would also have a last name, and then the last name would just sit in there as well. They would have an age, and the age would also just sit in there. They would have, let's say, for example, a gender. Okay, and the gender would just sit in there also. So, and this was case sensitive, the element. You can see all I'm using everywhere here was basically different elements that has an opening and a closing tag. And then if you wanted to show these particular salesperson's customer, you would basically have like some sort of customers element, and that customer element would have, it would have a customer, customer like so, and this customer would have a name, and then maybe this will be MS, and that customer would also have an address. So maybe 101 Main Streets. I don't want to break that down into pieces. And then would have another customer. Let's say one more information about the customer will be the credit limit for the customer, maybe 400,000 Rand, like so. And then if this salesperson has more than one customer, you would basically copy that same customer and paste it out here. And you can see this is the first customer, and this will be the second customer, and this can be ITT. This is 102 Main Boulevard or something, and maybe the credit limit is 500,000, like so. And then this is how an element-based XML worked for the longest time. Now, the problem with XML is when you send XML back and forth, as you know, you send it from one system to another system. Each system adds an additional payloads on the XML, and the XML document grows tremendously. And obviously, there was also lots of people were looking for ways to sort of make this more lightweight and so on and so forth. And well, a document DB using something called Json got created, and that's the subject of the Cosmos DB database. So I mentioned earlier that this example that you're looking at is an element-based XML. If you wanted an attribute-based XML, you could do the same thing by saying that you want to have a salesperson like we had, but inside the salesperson, you would have an attribute called that. You would also have a last name attribute called OGO, NGO, and then you would have an age called that. You would also have maybe a gender attribute, which will be a male. And then the way that you close an attribute for an XML document will be a / close, like so. Okay, so this will be one XML document. If this XML document, like salesperson, which is closed here, has a number of customers in it, well, the way you would represent that is by not closing it this way, but by using the closing tag for sales, like so. And in here, if you have a customer element, and the customer will also have a name, it'll be customer name. The customer will also have an address, like so. It'll be 101 Main Street, like we've looked at. And then the customer then will be closed with a / right closing bracket or angle brackets. You can have another customer with the customer name equal to customer name 2. And this customer can also have an address, 202 Main Street, like so, and so on and so forth. So the choice that you make between as a developer when building application, the choice that you make between a database storage always ranges from either using a relational management systems where you create multiple tables and you relate the tables together like so, or you use an XML document to sort of store your data. And obviously you have either the choice of using an element-based XML, which is the first format that we have here at the top, or an attribute-based XML, which is this one that you have over here as well. So, and I told you also the limit. One of the reasons why XML, even though XML is still in use, didn't really pick up very well was because of the size of the header over time. It just grows tremendously, and that can be an issue going forward there as well. All right. So to Liz, while you unmute yourself. Okay, so any questions? Anything you need clarifying? I mean, obviously, like I mentioned earlier, the relational management system is still a very formidable type of ways in which your applications can store information. However, there are several other options as well. It scales very well. You can store hundreds of millions of records in a relational management, but you start to experience performance degradation when you actually query them, which is one of the reasons why the choice of looking for other ways of storing data became apparent. And XML also really didn't cut it because you can't store a large amount of information in a file. It just has a limit on the file system also. And then a new type of data storage became apparent. And that new type of data storage was called JSON. So JSON data storage, which is essentially called JavaScript Object Notation, JSON. And if I were to show you what it looks like, I can go back to my web project. And in my web project, I can add a JSON file to my web project. And I can just say customers, customer lists, okay? But the extension of the file is always gonna be JSON, all right, JSON. And a JSON file always begins with an open and a closing curly brace, okay? An open and a closing curly brace. All right, so the structure of a JSON file, it's essentially a key and a value, okay? A key value pair. So on one side is the key and on the other is a value. And you can already see how this would make sense because the same data that we represented earlier, we can do the same thing here. So if we have a, and the one thing that you need to know is that you need to wrap both the key and the value in quotes. So if this was a salesperson ID and the ID is 0001, like so, and then you'll put a comma at the end of it. And then you would also begin a first name like so, and then you would have first name, you would have a comma, you would have a last name, and the last name would also have a comma, you would have an H, and the H would have a some sort of value as well, and then you would have a gender, okay, and the gender would also have a comma by having a value like so. And then if you wanted to, so there are some interesting caveat in how a JavaScript object notation actually stores information. You can, for example, if you wanted to have, say, for example, this particular salesperson has a, multiple customer that it manages, then you would just say customers. You also have to always wrap that in a multiple quote like so. And then you would create a new object so you can see the open and the closing curly brace that was used initially became, you can also have a sub of that inside a new key. So this is a key for customers. And then here you can say that, oh, this customer also has a customer ID, like so. And the customer ID, maybe it's 100. And then it would have a customer name. So maybe this customer name is Microsoft, like so. And then maybe you also have like an address for this customer. Okay, and this will be a way in which you would have a particular salesperson that has one customer. Now, the question becomes, What if you have what if the salesperson has multiple customers? Then how do you manage that as well? So what you do is you wrap the object of that particular customer key in an array, like you can see. So, and this would then allow you to be able to have more than one object in that array as well. So you can see that after you've wrapped that object, the initial object that we had, we can now have multiple objects inside of it as well. So you can see this particular object here. We just have a comma, and then you would have a 200 customer. Let's say it's called IT Think Smart Solutions, like so. And then you would have an address, so 102 mainstream, and there is absolutely no limit of the number of I can think of a company, ABC Corporation, like so. Maybe they are on 103, and so on and so forth. So now, if you also wanted to have more than one customer, more than one salesperson, well, it's simple. Just wrap the entire objects like so in an array, and then you can essentially just create a new object such as this one, like that. And then you can come in here. Remember, this is the opening and this is the closing for that object. And then you put a comma there and you just paste another customer there as well. So you can see we have, so this will be say 2, and this will be Sarah Jones. This will be Jones. Maybe she's 35 years old or 33 years old, and she's a female. And then she would have her own customer, so maybe a customer 400, and a customer 500, and then a customer 600 as well. And obviously, these customers would definitely be a different company. So I can say XYZ Corporation. And then here I can say this is Alpha Smart Solution, and then this could be anything, Streamline Tech or whatever you want to call it. So what you would have achieved would be a very well structured XML document. And if you look at this is something that you can serve in the browser. It's actually quite powerful. So because of, and it doesn't have as much payload as, well, it doesn't have any payload except for the data payload like XML. And, the performance with which you're able to retrieve something from this database became enormously fast. I mean, if I retrieve, and this also sort of goes very well with the way in which most application uses, data. If I go on, if this was a product and these are product details, for example, if I go on a website, I get shown the product with an image, and then when I click on the card, then it goes in and it shows me details of that particular product. Or if I were to be building a site and I want to show all the salesperson, and when I click on a salesperson, I want to show all the customers that they had. Each and every single one of this information is super fast. There's no join required. There's no heavy query that you need to write. So a lot of companies started looking at, moving to this particular type of data structure or this particular type of databases as well. So the first company to make a leap in terms of creating a database software was a company called Mongodb. So Mongodb is it's when it comes to document databases, MongoDB is a household name. So if you have never heard of MongoDB before, and you're a developer, you should definitely look into it. One of the first company to sort of run entirely their online platform on MongoDB was Walmart. They run on MongoDB. But so if you go to MongoDB, this is the first company to implement an entirely fully functional documents database system. And I mean, look at the guys who are running them. eBay runs on MongoDB, Forbes, Boxed, Rent the Runway, and Coinbase. And there's thousands and thousands of companies that basically run on MongoDB as well. And MongoDB is free, so you can download a community edition, or if you want a commercial edition, you can also download those as well. It's available for support. You can see how much I mean, there's a serverless option, there's a shared hosting option. You can try that for free as well. It tells you that you have from 10 gig to 4 terabyte of storage, 2 gig to 768 gig of RAM. I mean, this is super, super enormous in terms of the amount of information that you can get. And this is a software that you actually download and install locally on your machine. And I believe I'm running Mongo on my machine. If I go to Mongo, you can immediately see I'm in the Mongo. I'm in the MongoDB console, and I'm looking at what is called a text, instead of, so I'm going to show you guys some comparison between MongoDB and, and the relational database. So for now, I just don't want to get into it. So if you fill up the form and you create an account or you sign up with Google, you get a link that allows you to download MongoDB. I think it's about 180 megs. It's actually not that big. And, let's just say type, and then I'll see all the software. I think I recently installed on my machine too. But yeah, it's quite a small file. It downloads very quickly, and then you can install it on your machine, and then you can write your applications to read and write into this MongoDB database. To show you some examples of the type of information you store in MongoDB, I'm going to open up one application from this project. Actually, let me just open it up directly. If I click File and I say Open, and I go to Solution, I could do that also by looking at quickly end this slide for now. Just my intention was to just do this for 10 minutes. Let me open Visual Studio Code. And we are going to be using this a little bit later on. If you take a look, this is an example of the type of storage or data that you would have. And if you take a look at this, I mean, this looks very, very similar to what we were talking about earlier. You can see it's got an array at the bottom, which allows you to have more than one. So this is a combination of categories of product and multiple products inside of it. So you can see you have an object, and that object has an ID, it has a name, LL Fork, it has a category Forks, and it has a description. Then it has a product, and that product is an array, and it has one product in it. So this just happens to have one product, and you can see the detail of that product. It's got, the name, the number, the category, the color, the size, the weight, the list price of that particular product as well. And you can see this image here, which is called photo, is pointing to a fork.jpg file representing the image for that particular category, not for the product. You can see the photo for the product is here, and the photo for the category is also here as well. Now, if you look at another category, which is ML Road Frame W, this one has more than one product in it. So you can see product categories, subcategories, and you can see there lots of, so how many products does this have? So 1, 2, 3, 4, 5. So that one has got 5 products. And the structure is exactly the same. This one has got quite a few more products, 3 products, and so on and so forth. So this is called a document database, and everybody's crazy about it these days. And even Microsoft has implemented a version of the Cosmos DB, of the document database, which is called Cosmos DB. Oh, yeah, that was a mouthful. So all of that to come down to explaining what Cosmos DB is. I hope it was worth it. Okay, so before I get into Cosmos DB, any questions? You know, I also forgot to mention as well that if you wanted a version of MongoDB that is not an installable version, you actually have the ability to go on what is called MLab. So it's called Cloud Mongo. So let me just quickly go to Google and say Cloud MongoDB, and I'm sure it's called MLab. So it's a version. It's basically a cloud, a managed service that is provided by, let me just say MLab. Okay, DBAS by MLab, yeah, that's the one, but I'm looking for the MLab website itself. So you can go on MLab and you can sign up. Yeah, this is their doc websites. So you can go on MLab, you go on their homepage. Actually, create a database subscription. Yeah, this is it. So if I take out the doc there and I press the enter key, you can see that this is a, you know, even though it was MLab, you can see that this is actually MongoDB Online, and you can sign up for a cloud version of it. So the difference is that you wouldn't have to maintain the database yourself on your local machine. Someone else would sort of take care of that for you, and you would just get like connection strings that allows you to connect to, you know, MLab to be able to use it as well. I think it was also called Mongo Atlas. So Mongo Atlas, I know, is a commercial version. A commercial version of it. Okay, so there's a few applications that I've built in the past with, you know, MongoDB and also with MLab. So Microsoft has a version of its own, which is called Cosmos DB. So let's quickly go through this and talk about some of the feature that separates Cosmos DB from all other document databases. So in case you want to know, there's a lot of different document databases available in the market today. I mean, like, you have Cosmos DB, you have Cassandra, you have CouchDB, you have MongoDB, and the list just goes on. So there's a lot of companies that are basically building, you know, document databases that you can use for your applications. They have equal performance. They provide same type of functionality. You know, obviously you get different types of support from the company, but pretty much the same functionality is available across the board as well. So in this module, we're going to talk about Microsoft's cloud version of Document DB, which is called Cosmos DB. We're going to explore Azure Cosmos DB. We're going to talk about it. We're going to look at every piece of it and talk about what makes it tick, what makes it strong. And then we're going to talk about how to implement what is called partitioning in Azure Cosmos DB. This is going to be one of the edge that Cosmos DB has on other, you know, other document databases, the fact that it runs in the cloud. And obviously it can take advantage of the elasticity in the cloud, which means it can scale to, you know, any amount of heavy transaction. It can scale to, you know, any sizes, any locations. We're going to talk about that. And we will look at how to work with Azure Cosmos DB in code. You know, for some of you who have some C# knowledge, and you get an opportunity to see how you would create an applications that would write and read information from Cosmos DB. So let's talk about the introduction to Cosmos DB. So after completing this module, you'll be able to identify the key benefits provided by Azure Cosmos DB. You'll be able to describe the elements in Azure Cosmos DB accounts, which is basically the highest hierarchy for Cosmos DB. So the same way we had to create a storage account, you need a Cosmos DB account. And then we would also look at how they are organized. So Microsoft has done some really cool and intelligent thing with Cosmos DB. So even though it's a it's a document database, if you want to be able to, if you want to query your document database by using Transact SQL, which is like select star from a database name specifying some criteria, there is a type of Cosmos DB database that you can create specifically for that. It's called Core SQL. If you want to be able to use the MongoDB API and query it just like you're querying a normal MongoDB API, there is a Cosmos DB versions for MongoDB. In fact, if you currently have your application running on MongoDB, you can switch to Cosmos DB by just changing the connection strings, and you don't have to do anything in your application. It would just be able to write and read from Cosmos DB like it was actually a MongoDB, provided you use the MongoDB API version. And then there's also one for Cassandra as well. So when we get to that part, we'll sort of talk about some of the key benefits and how Microsoft has organized the Cosmos DB account and how you can go ahead and create one as well. We will also explain the difference between consistency level. So consistency is something that whenever you discuss a database, irrespective of if it's an RDBMS, relational management system, or a document database, consistency is key. And the one way of describing consistency is basically by using the keyword ACID. So ACID, and A stands for atomicity, C stands for consistency, I stands for isolations, and D stands for durability. And we will talk about how different types of options that you create in Azure Cosmos DB can have different consistency level and what options you might choose when you are setting up your Azure Cosmos DB in Microsoft Azure as well. So we would explore the API supported in Azure Cosmos DB and choose the appropriate API for your solution. I mentioned earlier you might want SQL API on Cosmos DB, so you can write Transit SQL against the Cosmos DB, or you might want a MongoDB API on Azure Cosmos DB, so you can write MongoDB query on the Azure Cosmos DB, or you might want a Cassandra. All of these APIs, we will talk about them and discuss how you can create them as well. Then we'll talk about the what is called a request unit, RU, and how it impacts the cost of the type of Azure Cosmos DB that you would create. So request unit is how we describe the unit of resource that is allocated for every request that you send to Cosmos DB. So we will get a chance to talk about how that can impact your cost and how you can make the appropriate choice in terms of what RU is more appropriate for your project as well. And then obviously, finally, we would end this module by looking at how to create an Azure Cosmos DB resources by using the Azure portal. So we will go into the portal, we will create an Azure Cosmos DB, and we'll look at all the options available there as well. Okay, so like I said earlier, one of the key benefits, or one of the key differentiator between Azure Cosmos DB and other document database in the market is essentially one, global replication. So and it's able to boast of global replications because Azure Cosmos DB runs in the cloud, which means if you create an Azure Cosmos DB account in the South African North region, for example, you could choose to replicate that database globally to every region in the world. And what would happen immediately is that a copy of your database would be created in all the regions of the world. So someone from the US wouldn't have to connect all the way to South Africa to access that particular Cosmos DB database. I mean, it's globally replicated, so, and it's done in a synchronous manner. So I sort of gave you an idea of what synchronicity is in the previous module, like changes must happen on all the global database before the changes are confirmed on the primary initiation, so where you actually started the change from. So if you say update customer name to something else, where the customer name is something else, and then you execute that command before you get a result that tells you that the update is completed, those changes would have reflected on all the global region where your Cosmos DB is created as well. And also the nice thing is that you can decide to choose either to do a local replica of your Cosmos DB database, or you want to do a global replica of your Cosmos DB database. So one of the key benefits is global replication, automatic and synchronous multi-region replication, and it also supports automatic and manual failover as well. So if something happens to the South African region, I can fail over my applications to a completely different location. That would help increase the availability of my application as well. So like I also mentioned, consistency in data storage retrieval and are basically one of the key benefits of Azure Cosmos DB. So it has varied consistency level. There are 5 consistency levels that we're going to talk about. This allows you to be able to offer your customer very, very comprehensive SLA in terms of how atomic, consistent, isolated, and durable their database transactions is as well. So it offers 5 consistency model, provides control over performance consistency, over trade-offs. So sometimes if you want better performance, you might lax on the consistency just so that you can get performance. And like I said, it's backed by comprehensive SLA as well. So low latencies, you can see it's served in less than 10 milliseconds read and 10 milliseconds write request at the 99th percentile. I mean, 99% of the time, all your request, or your read request and your write request would happen in under 10 milliseconds. And like I mentioned, because your Azure Cosmos DB is running in the cloud, it benefits from the elasticity of the cloud. So elastically, it scales through from 1 to hundreds of millions of requests per second across multiple regions as well. If you were to set up a version of Cosmos DB on premises, well, the request that the Cosmos DB can serve per second would essentially be limited by how big the server is. So if you have a medium-sized server that can serve maybe 100 requests per second, if you want to increase the number of requests per second that can be served by the server, you would have to essentially buy additional server and scale the request across those multiple servers as well. So because Microsoft Azure almost has infinite amount of resources, your Azure Cosmos DB will be able to take advantage of that, kind of scale, and it would allow it to be able to scale out consistently and scale down as and when it is required as well. Any questions? Is this making sense, guys? Or am I just
Yes, it is.
all right, cool, awesome. So essentially, the next time you're thinking of building your own application and you want the cloud to be the choice of hosting your application, so maybe if you want to host your application in the cloud or in Microsoft Azure, you certainly have to think about. Sorry, can you say that again? Akani? Okay, I see Machapa has got his hands up. Can you go, Machapa?
Can you please elaborate more on global replication? Like, you were too fast, I didn't hear you well.
All right, cool. Let me give you an example, right? I'm gonna do MS Paint, and then I'm gonna expand this. So let's say we as a company, IT Think, right? We have decided to go into cloud offering, right? So we want to do, what a normal traditional cloud provider would provide. So, and we set up a data center, say in Randburg. Okay, so this is our data center in Randburg. In here, obviously, we have servers, and we have servers, endless amount of servers. And one of the things that we offer on our data center is basically Cosmos DB. Okay. Okay, I can't write on this thing. And then, so here you are you are looking for a cloud offering for document database, right? And then you found IT Think, like, oh, this is really great. I am going to use IT Think for my application. I'm going to host my application somewhere here, and that my application is going to be storing and saving data inside a database in the data center, and then all the read and the writes onto that database will basically come from that particular database, and that database is sitting in that location in Rambach. Now, we can't claim global replica of this database because we only have one copy here in the Rambach office. If anything happened and there's no power, or there's load shedding, or there's earthquake, and this becomes unavailable, right? Your entire application and database becomes unavailable. Are you with me? All right.
Yes.
Now, but what if we have, we have an office in Rambach, right, here in South Africa. We have another data center in the America. We have another data center in Europe. We have another one in Egypt. We have another one in, you can name it, all the countries of the world. And somehow all these data centers are linked together in a way that allows that whenever you create a database here and you create an application, you can choose for this database to replicate, which means keep a copy of the database here, keep a copy here, keep a copy here, keep a copy here, right? And not only do you want to keep a copy there, you also want to take your application that you have here, you want to keep a copy here also, and keep a copy in all this location. So if someone from Germany, for example, right, were to try to access your application, they will be pointed to the replica of your application in Germany, in Europe, because that's the closest with the best latencies for them. If someone in Egypt were to access your applications, there's a copy of them here. If someone in America were to access, there's a copy of your data here. But when they make changes to your data here, that change is committed across all the database of all the locations where you have a copy. And this is called global replica. Does that make sense now?
Yes, it makes sense. So, say,
Go ahead.
If I have my application replicated globally, does it charge the same way when it?
That's a brilliant question. No, it doesn't. So global replica of your database, of your Azure Cosmos DB is going to cost more. Yeah, so it's definitely going to cost more.
All right, sir.
Okay. All right. So can we move on now, or do we still have any other question? Okay, I will assume the silence. Akani, you wanted to say something earlier, but it was so brief I couldn't hear it. All right, but guys, remember, if you're struggling with connectivity, just go to the chat and then just leave a message there. I will see it. Okay, so let's talk about the resource hierarchy for Azure Cosmos DB. So if I wanted a database in Azure right now, this is going to be the hierarchy of things. There are 4 components that you need to be able to store your data. The first component is what is called Azure Cosmos account. So like your Azure storage account, you need an Azure Cosmos account. So an Azure Cosmos container is fundamentally the unit of scalability. So which means, and you can see the container is right here. So you create an account. The account, you create a database, and inside the database, you create a container, and the containers will contain the items as well. Okay, so I would create an account. This is unit of billing. for my Cosmos DB. So every transaction or request per unit that is processed by this Azure Cosmos DB will be charged to this particular account. So, and then inside that account, I can have one or more databases. So if I create a database, I can categorize my content in the database by using the concept of containers. And in each containers, I can have my items in there as well. So let's just look at all four of them. So Azure Cosmos DB transparently partition your container using the logical partition key that you specify in order to elastically scale your provisions, throughput, and storage. Now, we'll talk about this in more detail, but the Azure Cosmos account is the fundamental unit of global distribution and high availability. Your Cosmos account contains a unique DNS name, and you can manage an account by using the Azure portal or by using the Azure CLI. We've spoken extensively about the Azure CLI as well. Or you can use basically your SDK if you're a programmer and you want to control this from code. So for global distribution of your data and throughput across multiple Azure regions, you add and remove Azure regions to your account at any point in time. Number two is Azure Cosmos DB. So at the root of your Azure Cosmos implementation is an Azure Cosmos account. Under the Azure Cosmos account is the Azure Cosmos database, and you can create one or more or multiple Azure Cosmos database on your account. A database is analogous to a namespace. So like, you know, you can have a database for e-commerce, and in e-commerce, you can have a container for customer, for a container for products, and so on and so forth. And the database is a unit of management for a set of Azure Cosmos containers. So that's how you keep an eye on and say, okay, cool. This is a database for all of my e-commerce application. This is the database for my HR applications. This is the database for my finance application. And in there, you manage the unit of items by using a container. So an Azure Cosmos container is a unit of scalability, both for provisioning, throughput, and storage. We're going to talk about partitioning later on, and partitioning basically allows us to be able to sort of break down the data in our Azure Cosmos DB into units that can scale and that can be provisioned in terms of throughput and also in terms of storage management. So a container is horizontally partitioned and then replicated across multiple regions as well. So say, take your, for example, if you were to take a customer account and then you take, you create partitions based on customer ID, and each of those customer ID is a unit of distribution, and it's partitioned accordingly, and you can distribute them across multiple regions as well. Obviously, Azure Cosmos account depends on which API you use. Azure Cosmos items can represent either a document in a collection or a role in a table or a node or an edge in a graph as well. So you saw I created a document earlier for salesperson. That salesperson has a customer in it. That document could represent an item. If you have another salesperson with another customer in it, that could represent another item as well. So when you deal with Azure Resources, when it comes to Cosmos DB, remember there's four different anchor here. So at the root of it, it's a database account, as you can see right there at the top. So this is your Azure Cosmos DB account. And inside that you have databases, and then inside the databases you have container, and containers contain items, and also containers contain, like I said, unit of scalability and distribution and partition. So hence it has the concept of store procedure, user defined function, merge procedure, triggers and conflicts, and so on and so forth. So if you're familiar with RDBMS, you will know what a store procedure is. A store procedure is a name query or a name SQL. If you want to execute something and you give it a name, it's equivalent to a function. It comes with a containers, or you can create it at the container level as well. So container, depending on the Cosmos API, container is realized as either a collection, a table, or a graph. So a collections will be a collection of salesperson, or it's collections of customer, or it could be a table if it's a table, and then in the table you would have multiple rows, or it could be a graph. In a graph you would have multiple nodes. So depending on the Cosmos API, an item can be realized as a document. So document live inside a collection, role lives inside a table, node lives inside a graph, and edge also lives inside a graph as well. So let's talk about consistency, all right? So consistency, Azure Cosmos DB approaches data consistency as a spectrum of choices, instead of two extremes. So you have between 5 different choices. The strongest consistency is called stronger consistency, and the weaker consistency is called eventual consistency. And in between, there's that trade-off. So you can have a bounded staleness, you can have a sessions, you can have a consistent prefix in between the two as well. So let's talk about the strongest and the eventual, right? A strong consistency and an eventual consistency are the end of the spectrums, but there are as many consistency choices as along the spectrums as well. The consistency level are region agnostics, and they are guaranteed for all operations regardless of the region from which the reads and the writes are saved at. So let's take it one at a time, and then let's just break it down and look at what this means. So with a strong consistency, when a write operation is performed on your primary database, now think about this very, very carefully. When you go to a site, an e-commerce site, and you say, oh, I'm changing my profile information, right? And then you log in with your username and password, and then you go to your profile page and you say, okay, cool, I want to change my profile information. And then you decide to change your phone number. When you click save on the phone number, the write operation is replicated to all the replica instances. So if you decide, you can decide that, okay, yes, I want to do global replication or the global replica, but I only want to do it to America and Asia, right? So when you use the strong consistency, when you click save, that information is replicated to America and Asia before you get a confirmation of your save. So the write operation is committed and visible on the primary only after it has been committed and confirmed by all replicas. So which means you can't lose information. So as opposed to the eventual consistency level, where you would save something on your profile or on your profile on the e-commerce website, and it would save it immediately on your local database and give you a confirmation. And later on, at some point, then it would save it to the Asia, or it would save it to the US replica of your database as well. So that's the key difference between the strong consistency and the eventual consistency. And then in between, you can see the bounded staleness. This level is similar to the strong level, with a major difference that you can configure how stale document can be within the replica as well. So the bounded staleness is usually the most recommended. You get the strong consistency, but you can choose how much latency you want to allow between you saving and then saving in other replica as well. So essentially meaning I can say my bounded staleness is 20 milliseconds, which means whenever I hit save in 20 milliseconds, it must write to all of the other database and show me as well. I mean, this is a way in which you can basically meet some sort of service level agreement. You know, if a client tells you that they want to make sure they have strong consistency across their multiple replica, at the same time, they don't want transactions to take more than 10 seconds. So in this case, you would use a boundless staleness, because then bounded staleness allows you to be able to specify a strong consistency, but with a staleness which refers to the quantity of time or the version count a replica document can be behind the primary document as well. So a session consistency is like strong consistency. This level guarantees that all read and write operations are consistent within a user session. So it only applies to the user session, nothing outside of the user session. So within the user session, all read and write operations are monotonic and guaranteed to be consistent across primary and replica database as well. Remember, this only applies at the user session level. Okay, So finally, you have the consistency preface. This level has loose consistencies, but guarantees that when update shows up in the replica, they would show up in the correct order as well. So this is not essentially about how consistent the update is. This is more about how the updates arrived in the replicas that you have. So like in the order that they have been made, they must arrive in that order as well. So that is according to your prefix of the order of the update without any gaps in between as well. So these are the 5 consistency level that exists. So whenever you talk about Azure Cosmos DB, and you're talking about a consistency for read and write operation, you need to know that you get a high throughput of less than 9%, 9 milliseconds for read and 9 milliseconds for writes, and in 99% of the time. And you have 5 consistency options that you can choose from. The strong consistency level, which guarantee all write and operations will happen on all replica before you get a confirmation. And you get a bounded stillness where you can specify the time in between. You have a sessions where, you know, guarantee consistency as long as it's within the session. You have a consistent preface where you just guarantee that everything would arrive at the replica in a certain order. And then you have an eventual where changes are committed. So you can see the level has the looseless consistency and essentially commits any write operations against the primary immediately. Then replica transactions are asynchronously, not synchronously, asynchronously handled and will eventually, over time, be written or be consistent with the primary as well. So this tier has the best performance. So, which is why I was saying earlier, sometimes you have to make a trade-off between performance and consistency or durability. And because the primary database does not need to wait for replica to come in to finalize this transaction, you get a sense of a high performance in this regard as well. Okay, so I think we should take a tea break. I feel like, yeah, that's already 2:21. All right, let's just take a short 15 minutes tea break so you can absorb some of those information. And then when we come back, so let's say we come back. So we have 9 minutes plus, let's just say 10 minutes and then, yeah, 14:35. All right, so let's take a tea break, guys. Stretch your leg, absorb the information, and I will see you right back at 2:35. Thank you. Okay, we are back. See, there's quite a few people that have jumped off as well. We still have 20 more slides to go through, so I would just start, and then the rest of the guys can just catch up with us as we go. Okay, so we've been discussing Azure Cosmos DB, and we said that Azure Cosmos DB is a document database by Azure. It provides some very impressive characteristics that makes it a choice for building application. One of them is global replica, consistencies, and so on and so forth. And we've just looked at the spectrum of the consistency that it provides. And then the next thing on the list is basically choosing the right consistency level is important. However, when you are choosing, or when you're creating an Azure Cosmos account, you have to choose one of few choices as well. So number one is the SQL API and Table API. So let's quickly talk about what that means. So you know how I explained to you earlier that, and guys, please, I can't see the screen. So if anybody pops back in, can you maybe just help me admit them as well? Okay. Okay, cool. So we spoke about how everything started from a relational database management system, right? What that means is that when you are building a relational database, the way that you retrieve information from it and the way that you write information to it is by using Transact SQL or some kind of SQL language. And the SQL language it's a very mature language. A lot of schools and universities and a lot of corporate organizations are still using it to today because they're still using the SQL environment quite consistently. I mean, a lot of the banks around here, a lot of the insurance companies, if you go in there, they're either running Oracle or they're running SQL as well. So even though there is document database for the cutting edge technology and really fast transactional processes, there's still a lot of legacy applications that is running on a relational management system. So Microsoft was quite, smart in making sure that imagine that you can create a document database, in this case, Cosmos DB, but the way that you query it, the way that you write to it, the way that you read from it is by using the Transact SQL language. I mean, I thought that was really brilliant. So because every single resource with SQL knowledge can immediately and instantaneously start working with Azure Cosmos DB without having to learn any new language as well. So that is the SQL API and the Table API. So it allows you to create a document database, but be able to query it with SQL API and Table API as well. So for many real-world scenarios, session consistency is optimal, and it is the recommended option. So if your applications require strong consistency, it is recommended that you use the bounded stainless consistency level. And if you need the highest availability and the lowest latency, then use the eventual consistency level as well. So we've spoken about all these different consistency options that are available. Okay, cool. Second is that Microsoft is also aware that there are lots of organizations that are currently that are currently running on MongoDB, Cassandra DB, and Gremlin APIs and Gremlin DB. And what they've done is they've also allowed you to be able to provision a Cosmos DB and have native support for wire protocol compatible with API for popular databases. So meaning, if you know MongoDB and you know all the APIs your applications can write and read to MongoDBs, you can create a version or a type of Azure Cosmos DB that has the MongoDB API. So meaning you can bring all your existing MongoDB knowledge into, Azure Cosmos DB. If you can create a version of the Cassandra API, so you can bring the Cassandra API into it. You can create a version of Azure Cosmos DB using the Gremlin DB, and you'll be able to use all the APIs from Gremlin as well. So this includes MongoDB, Apache Cassandra, and also Gremlin as well. So when using Gremlin API, the default consistency level configured on the Azure Cosmos account is basically used, and the default consistency level is essentially going to be the second option. Just give me a second. Bounded stainless is the second option there as well. So consistency basically guarantees for read operations correspond to the freshness and the ordering of the database states that you request. And also read consistency is ties to the ordering and propagation of the write update operations, just to ensure that whenever you are reading information from a database and someone else is making changes to it, you are reading a consistent version of that information, not some sort of data that is still undergoing changes as well. Excuse me. So the probabilistically bounded stainless matrix provide an insight into how often you can get a stronger consistency than the level that you have currently configured on your Cosmos account as well. Okay, so let's look at the supported API. So when you go into Microsoft Azure and you choose to create an Azure Cosmos DB, you have to choose these options. So either you use the core SQL API for MongoDB, Cassandra API, Table API, or Gremlin API. What this means is that if you choose the core SQL API, this API stores data in document formats like a normal document database, but it offers the best end-to-end experience as we have full control over the interfaces. So Microsoft has got full control over this because this is their native SQL database API. So you would be able to query the document database by using Transact SQL. So your normal select star from, and all of those transactions all of those query language will work in this regard as well. API for MongoDB, well, what this really means is if you have existing investment in terms of knowledge in MongoDB, this API stores data in document structure via the Bison format or the JSON format, and it is compatible with the MongoDB wire protocol, so you can use the MongoDB API on it. Cassandra API obviously is the same. It's a column-oriented schema and is wire protocol compatible with Apache Cassandra. And then you have a table API. This API stores data in key value pairs. And then the Gremlin API allows users to make graph queries and store data as edges and vertices as well. So essentially, the summary here is that these are the 5 different options available for you when you go into Microsoft Azure and you try to create a Cosmos DB account. So we spoke about request per unit. And one of the things that we talked about in the request per unit basically is that a request per unit represents the system resources such as CPU, IOS, IOPS, memory that are required for the database operations to perform the database operations supported by Azure Cosmos DB. So whenever you send a request to an Azure Cosmos DB, that Azure Cosmos DB will basically need to allocate a request per unit to service that request. And that request per unit is calculated based on how much CPU is required, how much memory is required, how much disk is required, which is the IOPS as well. So the type of Azure Cosmos account you're using determines the way you consume RUs. This is request by unit, and how you are charged for it as well. So there are 3 different modes that you need to know about. So first one is the serverless mode. The second one is auto scale mode. And the last one is provision throughput mode as well. So let's talk about it one by one. So let's say, for example, I'm creating an Azure Cosmos DB account. One of the options that I have to specify is basically the way in which I want to handle requests per unit. We know what serverless is because we've looked at Azure Functions. Azure Function is basically just serverless mode, and you don't provision any throughput when creating resources in your Azure Cosmos account. And at the end of your billing period, you just get a bill for the amount of request units that has been consumed by your database operation. So meaning you go in, you create your Azure Cosmos DB account, and it doesn't charge you anything until you start calling it. So whenever you call it, the request unit allocated to that call will determine basically, the amount that you'll be charged as well. So, but the most popular is basically the provision throughput mode. In this mode, you provision the number of RUs for your application on a per second basis in an increment of 100 requests per units per second. So meaning, think about it this way: every single time you need a request or RU, a request per unit, you will be provisioned a request by unit in the units of 100 per second. So whenever a request comes in, and that request would need to perform certain operations per second, that request will basically provision 100 RUs for you per second. So to scale the provision throughput for your applications, you can increase or decrease the number of RUs at any point in time in the increment or in the decrement of 100 RUs as well. So meaning you can scale up by increasing in the increment of 100 requests per unit, or you can scale down by decreasing in the increments of 100 per unit. And you can also make your changes either programmatically or by using the Azure portal. So you can provision throughput at container and database granularity level, whatever you want. So the last one is auto scale mode. So in this mode, you can automatically and instantly scale the throughput RUs of your database or container based on its usage. And this mode is usually well suited for mission critical workloads that have variable or unpredictable traffic patterns as well. This obviously does require some SLA on high performance and scale, and this would usually be the options that you would choose if you were doing like a very, high mission critical application and you want Azure to take care of, the number of RUs that are provisions whenever they are needed as well. Okay, so I'm going to go into Azure. So I'm going to open my browser, and here I'm going to go to portal.azure.com. Okay, I'm just waiting for the signing to complete. Okay, so once I'm signing, I'm going to create a new resource. And I'm going to say Azure Cosmos. Just bear with me. My internet is quite slow today. We struggle quite a lot also in the morning. And you can see I have Azure Cosmos DB by Microsoft. You have Azure Cosmos DB reserved capacity, Azure DB API for Mongodb. You can see, so the option that I want to choose here is actually the Azure Cosmos DB. So I'll choose that options there. And then you can see in the Azure Cosmos DB here, I would choose create. And it takes me into the wizard for creating Azure Cosmos DB. And this is where you get to choose the API that you want. So if you want to create a document database, but use the Transit SQL language to be able to query the document database, and also use the Cosmos client API from a .NET, JavaScript, Python, or Java application, choose the core SQL recommended. So this is the recommended core SQL native API for working with document, support fast, flexible development with familiar SQL query language and client libraries. So this would usually be the options that you would choose. But if you want a Cosmos DB API for MongoDB, this is basically a fully managed service apps written for MongoDB. Recommended if you have existing MongoDB workload and you plan to migrate to Azure Cosmos DB, this will be the options that you would choose. Cassandra is here if you want to be able to do workload around graphs. If you want to manage Apache Cassandra, this will be the options that you would choose. All right, and Azure Table is also here as well. So these are the 5 major workloads that are fully managed NoSQL database services for building scalable high-performance applications. So I'm going to choose the core SQL. It's recommended. It's a document database, but I'll be able to query this document database by using SQL query language as well. Obviously, the first thing that you do is to specify your subscription. I'm going to choose the Azure. The second thing I need to do is to create a resource group. So I'm going to create a resource group called Polyglot RG, GO. And then I click on the OK button. And then I need to give my my instance a name. So what am I going to call this Cosmos DB? So AZ204 Cosmos DB GO. Long name, but it's Azure 204 course. It's a Cosmos DB, and my initial is GO. I'm just going to put this in West US. And if you remember, we spoke about the options available when it comes to capacity mode. And I mentioned we have the provision throughput, where programmatically or manually you can increase your request per unit in an interval of 100 units per second. So if you want to be able to do that, you would choose the provision throughput. But if you want your Cosmos DB request per unit to not be charged until a request comes to your server, you would choose the serverless option as well. I'm going to choose the provision throughput per unit. And then here, so you can see the provision throughput per unit with this Azure tier filters, you would get 1,000 RUs and 25 gigs of storage for free in the account. And then you can enable free trial up to 1 account per subscription, estimated $64 per month discounts per month. So I am absolutely going to apply that to try and save some money. So, and also limit total account throughputs. I can limit the total account throughputs to the provisions to what is provisioned on this account so I don't get charged. And then the next thing I need to do, obviously, is to click the next, which is global distribution. So we spoke about global distribution earlier. If I enable global distribution, by default, global distribution is obviously disabled. If I enable global distribution, I'm going to show you how you can automatically choose the regions where you would like to distribute them to. So, but with geo redundancy, you can your database, your Azure DB will be provisioned in a pairing region. So West US is paired with East US and so on and so forth. So if your region, like I chose the, if you saw here, I chose the West US option. If I choose the West US option here and I go to next global distribution, if I enable geo redundancy, it will automatically create my my global replica in the East US as well. You can also add more region if you want later. I'm just going to disable that as well. So the multi-region rights, basically capacity allows you to take advantage of the provision throughput for your databases and container across the globe so that you can perform a multi-region rights. But this is only relevant if you have enabled geo redundancy. In our case, I'm just going to disable both of them and then I'll click on the next. On the network, I can either allow my Azure Cosmos DB account to be available to all networks, so or private network, internal network, or the internet traffic, or I can basically specify a selected public endpoint. or I can just make it a private endpoint and it will be inaccessible from anyone on the internet, and I'll be able to access it from a private network. I'm going to choose next here. So Azure Cosmos DB provide 3 different backup policies. You will not be able to switch to periodic mode once you've adopted a continuous mode. So decide which one is basically going to be suitable for you as well. So I'm going to choose the periodic option, and you can see the backup interval. So every 240 minutes, my Azure DB will be backed up. I can also choose the continuous 30 days. So every 30 days windows, I will basically be able to, a backup of my database will be created as well. So backup redundancy, to save cost, I'm going to choose local redundant backup storage, and then I'll click next on the encryption. This is also something that we have spoken about extensively as well. If you want to, you can allow Microsoft to encrypt all your data at rest and in transit. You do that by using the service managed key. So Microsoft will basically provision a key that will be used to manage your Azure Cosmos DB. But if you have your own key and you would like to bring your own key to Azure and use it to basically manage it, you can do that as well by specifying the customer managed key here. So I'm going to click next. I'll just leave that by default. I don't want to specify any tags. I'll click next again. And then you just let Azure do its thing, and then it'll come down and tell you that this, it'll do a validation, and at the end of the validation, it'll tell you if you are able to, if all the configurations are appropriate for the Azure Cosmos DB account creation as well. All right, let's give it a few minutes, or a few seconds rather, for it to perform the validation, and there we have it. The validation is successful. So now I can technically go ahead and create these Azure Cosmos DB. So I'll do that by clicking on the create button. Let's give it some time. All right, there we go. Our Cosmos DB provisioning is in progress. So these will be equivalent to you provisioning a database for your application. And in your application, you would write transact SQL, like SQL query, to be able to, query these databases as well. So one of the first thing I want to show you how to do is, we've just created an Azure Cosmos DB. I'll show you how to create a database, and I'll also show you how to load some data into it. And this is a fairly straightforward process, so just giving it time. If you have a question, if something is unclear, this will be a good time for you to either raise your hand or just ask your question.
Hi, Mr. Gideon.
Yes.
So I wanted to find out, the request unit, is it a automated process, or is there a service that it utilizes to process the request?
So remember, there are 3 options, right? You have the auto scale, which is automated, but obviously your charges is unpredictable. This is usually used for mission critical application. So you would just set it to auto, it will automatically increase by itself. The throughput one is manual, so you have to basically manually increase the request per unit. And you can also do it programmatically as well. So even though it's manual, you can implement it in code to automatically increase based on certain number of requests coming to the server, and it would automatically provision and deprovision the request per unit, right? And then the last option is obviously a serverless options where, you know, nothing is consumed. It's still going to be provisioning the request in units and an interval of seconds, but nothing is used until a request arrives on the server as well. Okay, I hope that makes sense.
Thank you.
Awesome. All right, so you can see immediately, as soon as the Cosmos DB database is created, I am able to sort of go into it. There are some quite important informations that we need here. You can see in the quick start is already telling us, hey, add a container, and then in the container, add some item in the container, and I can do that from here if I want to. And obviously, once a container is created, you can download the sample.NET applications connected to it that can extract informations, and then you can just build and run it. So that's really cool. And you also have those templates for Xamarin. You have a template for Java. You have a template for Node, and you have a template for Python as well. In the next module, what we're actually going to do is to look at some sample code. All right, and this sample code will basically show us, how we can interact with an Azure Cosmos DB from a client application. So I also want to go to Data Explorers. And obviously, at this point in time, I don't have any data loaded here. But from here, I will also be able to create container, create partition, and then, load some data in it as well. So you can see currently we don't have anything. I can launch a quick start, which will take me back to that quick start. I can create a new container or for storage and throughput, and then I can connect to your existing container from here. So let's just create a new database. So I'm going to create a database. You can see I need to specify database ID. So I'm going to call this customers. And you can see the options that I'm using at the database level is the provision throughput. And provision throughput at the database level will be shared across all collections within the database. So meaning any collections that I create in it, for example, would automatically use the provision throughput. And remember, provision throughput would be that every request that requires a request unit will be provisioned in an interval of 1 second, and it will be provisioned at 100 RUs per second. So you can see there, you also have the option to choose the auto scale. So auto scale for hours, because we created it and we chose that we wanted to use, Microsoft offered us a 1000 RU for free. So that is what you are looking at there. So your database throughput would automatically scale from 100 RU per second. So this is the 10% of the maximum RUs that you have committed to. And this is basically your RU based on usage. And then it would also give you the estimated monthly costs in USD. You can see between $8 and $87 per region. Between 1 and 1,100 and 1,000 requests per unit, and this is how much it's charging you per request per unit as well. So it's a very, very small amount. If you choose a manual options, remember that you have to do the auto scaling by yourself. So in this case, I'm just going to do the auto scale for my customer. I'll click on the OK button. Let's give it some time. Okay, so if you take a look, you can see that in the SQL API, we have under data now, we have a customer. So you can see there, in there, I can create a new container. I can maybe call this, so I can just create a new container here. You can see I can choose your account is currently configured with a throughput of 1,000. This update isn't possible because it would increase the throughput. So if I want to, you can see the scale options that I want as well. You can still make changes to it here if you want to. I can also, if I want, I can delete this database. So I just need to copy the database ID. Click on the OK button. And then I can create a container, and then a container, I can create items in it. So I'm going to use the quick start to set up some items in the container in the Azure Cosmos DB. And the way that you do that is just go to the quick start options here, click on the create items in the container. It would automatically, so in these steps, you can see Cosmos DB data is stored in containers as opposed to in databases. So let's just give it some time. Absolutely slow. All right, cool. So you can see now my items container has been created with a capacity of 400 requests per unit throughput. And then to see your container, go to the Data Explorer. If you want to connect a .NET application to this container with the connection strings already done, just click on the download here. And you can see it'll download a zip file of the quick start. So if I literally come in here and I extract it, inside of that folder, I've done the extractions. You can see that it will, I'll sort of show you what it downloads in a moment. But if I go now to the Data Explorer, you will see that the Data Explorer now has a container, and that container is called items. And if I go to items in that container, I can create a new item. So currently we have no document in this particular locations. You see it comes with the store procedure, comes with triggers, it comes with user-defined function. So there's really nothing in here at this point in time. I can create an item. And to create an item, I can just come in here and create an item. So there we go. So even if I just come through in my Visual Studio earlier and I just copy, actually I can copy that as well. So let's go, let's take that item. So this is an example of an item that I can copy. Or if I want to, actually, let's use the other Visual Studio. Not that one, just give it a second. Not that one as well. I think it will be one. Oh. So let's just use this one. So I'm going to copy this guy over here. And then I'll go back here. And I mean, it's possible for you to come here and say first name, like so, and then you can put the first name there. You can do a last name. And then this last name can be there. And you can do an age. You can do a gender, like so. And remember that you could also, oh, I need to make sure there's a comma at the end of the ID as well. So this could be a salesperson who has an address. So I can say address. And that address could be an object, and it could have a street. So 150 Delport, city, and then city could be Pretoria, and states or province. And province could be Gauteng, like so. And when you're done, you click on save. You will see that the item would automatically be saved. And you can see there are certain, Cosmos DB metadata that is automatically added for you as well. Okay, so this is how you create, without wasting too much time, this is how you create item inside your Cosmos DB. If I want to query this, I can come in here and say new query. So I can say select start from items. And then if I execute this query, and look at that, the query result actually shows us the items that we had created. So if I say select start from items where age is greater than 30, I mean, obviously I only have one record, so assuming, let's try equal to 30. All right, says no record, but you get the idea, right? The idea is that you can write, you can create a document database, and then you can query it by using, transact SQL statements to be able to talk to it as well. And you could decide that you want to create, you want to do first name, last name from that, and then you can execute that. Severity, select this from items. I think I have to put could be the case, but if this was a normal transact SQL, okay, there we go. But there's nothing, it just shows empty because it's showing that as an empty. So if you just do that from items and you execute the query, you will see the entire results of your item location as well. And then if you want to, you can create another items, and then you can come in here and specify that. You can say testing. Make sure you have a comma at the end of that, save it. Oh, I need to change the ID to something to some alphanumeric value. So it's unique. There we go. So we have the ID and you have testing. And if I go back to a new query now, and I say from items, and I execute this, and you can see that it technically retrieve both my record for me. So you can see there my record. So I have both records of the data that I specified earlier. So yeah, so basically that is essentially how you would work with MongoDB or Azure Cosmos DB. So what I want to do is I want to show you the project that was created just now. So as part of that Azure Cosmos DB, a project was also set up for me, and that project has an app.config. You can see that that app.config is connecting directly to this to this Cosmos DB URL. So you can see endpoint URL and primary key. I'm going to show you guys where you get that key in a moment if you also want to do the same. So you would create an application that has app settings, and it would have an endpoint URL with the value. You specify the URL of your MongoDB. You can see that's the one that I created. It's AZ204 Cosmos DB go.document.azure.com. And then column 443 is SS HTTPS. And then you can see the key that was created, the primary key that was created is also required for it as well. So this is basically some classes that were created for me. We'll talk about it just now on the slide, and I'll explain what it does. But most importantly, the Azure Cosmos reference is added to the project. And because of that reference, we're able to create a Cosmos client from the Cosmos client, and then we can use that to be able to manipulate the content of that database as well. So let's go look at how to do that. So on this exercise, we created an Azure Cosmos DB account. We add a database in a container, and we add data to your database as well. So let's talk about partitioning in Cosmos DB. So there are two types of partitioning in Cosmos DB. The first one is physical partition. You don't ever have to worry about that. Microsoft Azure takes care of your physical partition. So, but all of your logical partitions are mapped to a single physical partitions. Physical partitions are an internal implementations of the systems, and they're entirely managed by Azure. Logical partition consists of a set of items that have the same partition key. So it could be customers in the same location. It could be products that are sold in a particular regions only. So you could create partition that way. So a logical partition also defines the scope of your database transactions. So you can create a partition key based on user ID, and that would just automatically partitions the user based on the user ID. You can see Azure Cosmos DB collection is created here. You can have a logical partition, and it will be based on the user ID, and the user ID will become the basis of the distribution as well. So you'd have a partition that contains Andrew and Mike. You would have a partition that contains Bob, or you would have a partition that have the rest of the user as well. So pseudo range distribution of data over a range of possible hash value represents the partitioning as well. So choose a partition key for read-heavy containers. For large read-heavy containers, you might want to choose a partition key that appears frequently as a filter in your query. So if oftentimes, whenever you do like a query on your database, you say select star from this where the user ID equal to that, create a partition on that particular user ID. So query can be efficiently routed to only the relevant partitions, physical partitions, by including the partition key in the filter as well. So that way, if, for example, if you look in here, on a normal day, if you don't have partition, if I say do a star, select star from a particular table, and I say where the user is Alice, for example, it will start and look at all of the user before it eventually finds Alice, and it will still continue to see maybe there's more Alice, right? And then it would display the Alice that is found. So you're wasting a lot of resources searching through each and every single one of these users, whereas if you do a partition based on Alice, what the system will do would logically just group user based on partition, and it would know exactly where Alice is, and that's the only partition that will be queried. So you would have saved a lot of money and resource or request per unit going through all of the other partitions that do not contain the relevant information that you want as well. So using item ID as the partition key is always recommended. So if your container has a property that has a wide range of possible value, it is likely a great partition key choices as well. Obviously, item ID is usually unique. So for small read-heavy container or write-heavy containers of any size, the item ID is naturally a great choice for partitioning. So just to summarize on choosing a partition key has two components. One is the partition key path, and the other one is the partition key value. For example, consider an item with user ID of Andrew works for Microsoft. If you choose the user ID as the partition key, the following are going to be the partition key component. You will have a partition key path, which is the /user ID. Okay, so that represent the partition key path, and then the key part accept alphanumeric and underscore characters as well. So you can also use a nested object by using the standard notation. And the partition key value in this case will basically represent Andrew. So the partition key value can be of any string or numeric value. So it is best practice to have a partition key with many distinct values, like a user ID, such as hundreds or thousands. The goal is to distribute your data and workload evenly across items associated with this partition key value, so you can basically simplify your read access. So if such a property doesn't exist in your data, you can construct a symmetric partition key. This is basically an ID that begins with 1, increments by 1, and is just used to guarantee uniqueness of every single items in the system. This can be done by doing a concatenations from multiple properties of an item. So you can take item ID and item location or item color. If it will guarantee uniqueness, you can use a partition key with a random suffix, or you can use a partition key with pre-calculated suffix as well. All right, so that brings us to the end of that module. So the last section of this module is basically module 3. This is where we're going to be talking about some code. All right, so the first thing we have to do is to identify classes and methods that is used to create resources. So if you want to create items, what classes and methods are available for you. You can create resource by using Azure Cosmos DB, .NET V3 SDK. You can write store procedure trigger, use define function by using JavaScript as well. Okay, so let's say you create a console application, a very simple console application, and that console application has a main method, which is the entry into the console application, and you would like to create a container. You would like to create some item in an Azure Cosmos DB that you created earlier. So these are the 3 steps that you have to follow through. The first step is you need to get the container. So to get the container, you will need to create a client, and this client will contain the endpoint and the key. So let me show you where you find the endpoint and the key for this container. So I would go to the browser. Not that one. Okay, cool. Let me just end this quickly. And then let's go to here. There we go. So if you scroll down on the left-hand side, obviously, if I go to overview, in the overview, this is the URL that you're looking for. So you need to copy this. And then you need to save this somewhere safe, because if you are to connect to it from your application, this is going to be your endpoint URI. Okay, the next thing that you need is obviously your primary key. So the primary key would represent a unique key that is used to protect your URL. And as you can see, the primary key is right here. So that's your URL and that's your primary key. You would also copy that as well, and then you will paste it somewhere safe. Okay. Ooh, don't remove any equal sign at the end of it. So these are the 2 components that you need. So if I go back on the slide, you can see there that the first thing is I have a class called Cosmos Client. This is basically a .NET Client API that allows me to be able to connect to a Cosmos backend. When you create an instance of that client and you call it the client, you pass in 2 parameters. The first one is the endpoint, and the second one is the key. Okay, and then once you have the client, you can use the client to get, there's a get container method in the client. And in the get container method, you can pass in the database and the collection. So in our case, if you had a database called customers and you have a collections called items, you basically pass that in there. So that container would contain the database and the collection, the collections. You can create a type in .NET. This is how you would create a type. You're just creating a product. This is based on a product class, which is not visible on this screen. And that product has an ID, it has a name, it has a group, it has a diet, it has a price, and it has a quantity. That all that detail of that product then sits inside of the orange soda right there, like you can see it. Then if you want to create this item, I mean, if you look at this correctly, you realize this is very similar to the JSON object notation that we spoke about. So it has an ID, but instead of a column and a double quote, it has an equal sign because this is a .NET type. It has a name, which is orange soda. It has a group, which is beverage. It has a diet, which is false. It has a price, which is 1.5. And then it has a quantity, which is 2,000. And then once you've created this object, if you want to save this object in this particular container, you would call the container.createItem asynchronously, right? And then you will pass that orange soda inside of it, and you would execute all of this in an await async. So meaning you want to wait for this to complete before the result of that item is written to an item here, which is of the same type that it was created on as well. So creating item allows you to create a new item. Upsert item async allows you to be able to modify existing item. I mean, this is a very straightforward process if you are a .NET developer. I mean, this is really just about Azure development, but I would have loved to take you guys on a journey and show you how you would probably do this as well. But if you think about it, what is happening there, if I just scroll down a little bit to the very end. So this is, and I'm just going to create my own class. So if I create a public class and I call it product, okay, and that class can have a property, and that property, let's say the first one is ID. Okay, it can have one as well. So this will be a string, and I think it had a, let's take a look, what else was there? If you go on the slide. So I had an ID, name, group, diet, price, and quantity. So string name. Also string group. Okay, also string diet. Dot delete async. And lastly, I think this is also price. So this will be a double because it's price. So we'll call it price. And then I think the last one was basically quantity. So quantity can be also an integer as well. So quantity. Okay, so this represents the class, and this class will basically contain the objects. So if I want to create an instance of that class, I can then come into my main inside my main method. Where is it? It should be somewhere here in the main method here. So before the try, I can create an instance of product. So so let's say orange products equal to new product. And then here I can then specify an ID, let's say 10, name, let's say some product, and then let's say diet, group. I think there was also group there as well. So basically, we would do exactly the same thing that you saw here as well. So you just need to have comma in between them. So let's do this quickly. So comma, some product. So let's just say oranges. And then I know there's also group there as well. So let's say this is a group of beverage, and then diets, let's say slim diets or lean diets. And then it also has a price, and the price is a double, 50. And then it has a quantity, and the quantity is basically, let's say 200. Okay, so we have a product that we've created, and that product is called Orange Product. And then if I want to, I can just call Cosmos or Cosmos client equal to new Cosmos clients, like so. And remember, you need the endpoint URL, and then you also need the key or the primary key as well. So obviously I need to set the endpoint URL and the primary key. I can do that here. I can say string, also let's say private string endpoint URL. Because I'm creating my own, so I'm gonna put the URL there, and then private string prim key, because I think there's already one, like so. So this would need to be a semicolon. So I'll go to Azure and copy my endpoint URL, and I'll copy my key as well. And then I will be able to use the endpoint URI, not URL, like so. And then the prime key, when I create, so it'll be endpoint. Okay, let me just look at it one more time. I think I called it NPRI, NPRI. So that would be, yeah, NPRI. And then here it'll be prime key, like so. And then inside here, I can say products. I can create a product, and I can call it item equal to client. Okay, let's get the container first, so we can basically get a so you get the idea. Same code as you saw on the slide. You get the container. After you have the container in a container object, then you basically use the container to create item async. You pass the orange into it, and you put the result into the same type, which is product, and that would automatically create the product for you as well. So, so that is using the Microsoft.NET SDK for Azure Cosmos DB. You can basically, in a console application, you can create item into an Azure Cosmos DB as well. So let's further look at some of the things that you can do. You can now create a partition. Remember, because beverages represent unique categories that you can have in a product. So every product is going to fall into a categories of beverages. You can then access individual item document by referencing their unique ID property and their partition key, in this case, beverages, because every single time when you say, hey, show me all the beverages product, and then it will show you where the beverage equal to something, like orange, then it will show you all the orange beverages. So in this case, you can serialize the document into a specific C# by using the partition key. So we set up a partition key for beverage, and then you can call the container read item async, and then you can pass the ID and the partition key, and then you can make that call in an await async. You're using generic here, and then you can put that into an item responsive product, and then you can convert that resource into an item as well. Okay, so you can also perform some query. We spoke earlier about how you can use the SQL query to be able to query your Azure Cosmos DB. Same process here. So we create a Cosmos client, we pass in endpoint and key, we create a container, we pass in the database and the collections, and then we are able to use the container to get item query iterator of type product. So we want to do a loop through the entire item and then run through a query selection of select star from product, where P, select star from product P, where P the diet is equal to false, and all of that will come into the iterator. And this iterator is basically using the feed iterator of type product, which is a generic. And then while there is more results in that iterator, you can then take the iterator and then read the next async and put it into a batch. And then you can go through the batch and then decide what you want to do from there as well. So the block of code here is simply empty. All right, so here's an exercise where you can create resource by using Microsoft.NET SDK v3, prepare the environment, build a console application, create a database, create a container, run the application, clean up your Azure resources as well. So this is also something that you can do quite easily. Let me show you an example. So if I go to the command prompt, I have this thing called .NET. So a .NET is a .NET Framework CLI. So since Microsoft has gone open source with .NET, we usually have to create .NET applications by using Visual Studio, but we don't have to do that anymore. In fact, you don't need to have Visual Studio installed on your machine at all. You can just have Visual Studio Code, which is a free version of Visual Studio. So if I create a folder here and I just call it projects and product and I go into product CLS, I can come in here and say .NET new console, and I can say I want to create a hello world application. So when I press so I need to specify that option is a name, and then when I press the enter key, this will essentially create a console application for me, and that console application will be if I do a diet there, you can see that we now have a project. So if you want to find out, if you say .NET new H and you press the enter key, it will show you all the options available for you. So if I, let's say, for example, what type of project if I want to see what type of project I can create, I can basically use the -- list to be able to do that. You can see all of the options. You can run tests. So the new options create a new .NET project. So if I say .NET new, and then I say -- list like so, it's going to tell me that I can create all of this different project type. ASP.NET Core, which is web, ASP.NET Core, that ASP.NET Web API, Razor, and then I created a console application earlier, which is sitting somewhere here. So you just say, you can see this is a console application in C#. So the way that you would then do that is you would go up and say console. And then if you do -help here, it will also tell you what you can do as well. So like what options you can create. So language version, no restore, program main, and then there are several other options available as well. One of them is by saying name. So N stands for name, and then you can give your project a name. So in this case, if I say console app 2 and I press the enter key, you can see it will successfully provision a console app for me as well. If I want to, I can go to Visual Studio Code and I can click File, Open Project or Folder. I can go to my C drive. I can go to my user. I know it's in the administrator, and I created a folder called Product. And inside that product, I have two applications. One is the Hello World. The other one is the console app. If I open the Hello World application, and I want to save the one that I currently have, you will see that it created a Hello World application for me. So the Hello World application will just write a console.writeLine Hello World, which is great. But if I say .NET build and I press the enter key, it will basically say that, hey, you need a version of a recent version of, oh, sorry, I'm not inside any. So if I say Hello World, like so, and I say .NET build, this would automatically build my application for me. As you can see, the build succeeds, 01 is 0 error. If I say .NET run, that would run my application and just print out Hello World for me. You can see the Hello World is printed. If I do the same thing with the console app 2 like so, and I say .NET build, and press the enter key, it will automatically build that application for me. If I say .NET run, it will say hello, it will just print out Hello World. If I go into the application and I change the Hello World to Hello Gideon, hello Gideon, like so, and then I save this. And then I go to, I think that was the first one. I say .NET build, and I press the Enter key. You can see that is .NET run. And you can see this time around, it says hello Gideon instead of saying hello world as well. And if I want this project to be, a project that I'm going to use to build my application, and I can add a couple of namespaces here. So I can literally just put that at the top, put this here. And then I can start, like creating okay, and maybe I want it to be readable, so console.writeLine, enter the value for X. So on top of this as well, I can literally copy that and paste here. And then I can say enter the value for Y. And then I can say int results, it's got to X plus Y. And then here I can just say results like so, and I can say result.toString. Okay, and if I go back to my console application here and I say .NET build and I press the enter key, this will build my project. Just two warnings, nothing to stress about. If I say .NET run, it's going to ask me for a value for X. I can say 100, value for Y, I can say 300. You can see the result comes down to 400 as well. So you can, this is a normal console application. I mean, you can literally do quite a lot here. If I want to, I could create a public static main. Okay, but I'm wasting too much time now. But I mean, this is not a C# class, but if it was, we would have a lot of fun just looking at how you can build your application from a console environment. But in your labs and in your exercise, you would be able to go through the process of building your console applications, create a database container, which I've showed you how to do, and how to run your application as well. Just a few more things that we need to sort of do before we wrap up this module. Store procedures. So if you, let's say you want to execute a piece of code against your database and you want to give it a name so that you can call it quite often, you can do that by means of what is called a store procedure. So a store procedure actually is something that comes from SQL. It allows you to be able to create a name query. So in this case, we don't use the SQL to be able to do it. We actually use JavaScript, and it's hosted in the same memory space as a database. So request made within a store procedure or a trigger run in the same scope of the database session as well. So it's still managed within the same RU. So you create a new document, you can query the collections, you can update the existing document, you can delete the document as well. And these are some of the things that you can do with the store procedure as well. And then here's an example of a store procedure. It's essentially just a function that takes a parameter. The parameter is document that you want to create. You get the current context, you get the collection in the context, and then you create a document in that collection. And then basically you get the self link, you pass in the document to create into it, and you pass in a callback function. So the callback function in this case takes two argument, error and document created. If there's any error, it'll be sitting in the error property. If the document was successfully created, it will be sitting in the document created as well. So you can see there, you can then take the document created, call the set body, and pass the ID to be able to get the response for it as well. So this is basically an example. It could definitely be different from this as well. So all Azure Cosmos DB operations must complete within a limited amount of time. You can basically use a bounded executions to be able to do this. So specifically, like I said, stop procedure have a limited amount of time to run on the server. If an operation doesn't complete within the time limit, the transaction is rolled back. So it will automatically roll back as well. So a stop procedure obviously represents a unit of execution. If it doesn't execute, it would roll back within that time as well. So all functions under the collections object that perform a create, read, replace, delete documents and attachment returns a Boolean value that represent whether the operations will complete or not. And then you can use that Boolean value to be able to determine whether you want to complete the function or not. So if it's true, it means that the document will complete successfully. If it's not, then you can basically initiate a rollback process as well. So transaction is something quite important. Especially when you deal with databases. And this is something that also comes from a SQL environment as well. If you have 50 lines of code in the stop procedure and 25 of them execute successfully and there's an error, you do not want the 25 to commit to the system. You want the ones that have committed to the system or that have completed successfully to roll back, because the entire operation must complete as a unit of work. So JavaScript functions can also implement a continuation-based model to batch or resume executions. So meaning that if the function executes to a point in time and the time runs out, it can literally save the execution of that functions. And then when you rehydrate the function, it will continue from where it left off as well. So functions can return any value. You can use this value to be able to resume a long-running function after the server-specific time is over. So for example, you might have a function to upload millions of documents. If the server-specified time is over before all document is uploaded, you can return a pointer to indicate the current location or how far you are in the progress of the upload. And this will make it easier for you to resume the process in a new function iteration if you decide to perform that as well. So triggers are a way in which we respond to events that happens in the database. So you can create a pre-trigger, which is going to be something that will be executed before something happens. So this is the before executed, before modifying or creating a database item. You have a post trigger. This is after a modification as a call on the database. So if you create a user and you have a pre-trigger before the user is created, a pre-trigger can execute and log the fact that you want to create a user. And then when the user is created successfully, you can also have a post-trigger that would basically execute after the function is executed successfully as well. You can also create a user-defined function, which is basically used to extend the Azure SQL API query language grammar, and you can implement your own custom business logic, and you can call it like you would call a normal traditional stop procedure or a trigger as well. So this is how you create a pre-trigger. So it's called validate to do item timestamp. So what you're literally doing here is that if you are creating an item in a system that doesn't include a timestamp that indicate the time of creation, you can use pre-trigger to be able to add a timestamp to it. So we're creating a number of functions like before, and we get in the context and we get in the request that comes. So we have a request object and a context object. And when we can use the request to get the body, whatever is coming from that request will be sitting in the body of that request. And then we can check if inside that item to create body, request body, has a timestamp. If it doesn't have a timestamp, we can create a new object of type dates, which is called TS. And then we can just add a property on the item to create called timestamp, and we can call the TS and get the time for it. And then we can pass it back onto the set body as well. So that way, before that item gets created in Azure Cosmos DB, you automatically add the current time of the creation or before the creation of that item is created as well. All right, I know this was a long module, but I'm trying to just make sure that we finish all the modules so we don't have a lot of carryover. So this brings us to the end of module 4, Azure Cosmos DB. We've certainly gone through quite a lot here. We've looked at how to create an Azure Cosmos DB. We've talked about some of the different options available, the fact that you can create a Mongodb API for Azure Cosmos DB. Core SQL API, Cassandra for Apache, and also Gremlin for nodes and edges. We've looked at how, you know, we went through the process of creating a Cosmos DB core SQL API. We looked at how to create a database and a container. We created items in the container. We queried the container. We looked at how to download the project that already contains the key as well as the endpoint URL. And then we looked at how to use the Cosmos Client API to be able to create new item by defining our own classes that we can use essentially to implement this solution as well. All right, so by now, at the end of this module, if you were to be asked the questions, what are the benefits of using Cosmos DB? Obviously, consistency is one of them, and you have a spectrum of consistency where the on the high spectrum is a strong consistency, and on the low spectrum is an eventual consistency. You have in between the bounded stillness, you have and so on. So you should be able to describe this as well. And what types of apps would benefit from Cosmos DB? Well, if you have a globally distributed app and you want that app to be available across multiple regions, you can take advantage of the global replica option that is available in the Azure Cosmos DB as well. And then obviously describe the 5 consistency level. Can you give an example of an application that matches the characteristics of each consistency level? And then under what conditions will it be best to create a synthetic partitions for your data as well? If you have a category in the data that will be used in the filters, you can basically create a not synthetic, symmetric key when you don't have a key that uniquely identifies every single record in the database. All right, that brings us to the end of that module. You have a lab that you're going to follow. It's available on aka.ms/az204 labs, or the same lab is available on github.microsoft.com. Once you have your account, make sure you are able to complete those labs and those exercises as well. All right, guys, this brings us to the end of this module. We have just a few more minutes for anyone who's got questions. If you want me to expand on something, this would be a great time for you to be able to do that. Anyone got any questions? Okay, if you do not have any questions, thank you so much for joining the session. It's been a long day for me. This is the second session I'm doing today. I hope you guys enjoyed it. Mashapa?
Before you leave, Gideon, I posted question in the chat.
Oh, in the chat. Okay, cool.
That's long before.
Does the container in Cosmos DB equivalent to a table in a relational database? A collection in a container will be equivalent to a table in a relational database. All right. A container is a unit of throughput management for container, and also can be used for doing partitioning and also for managing replication, basically. So it's something unique and it's different for Azure Cosmos DB. I hope I've answered your question.
All right, now I got it.
All right, cool. Any other questions? Okay, if there's no further question, thank you so much, guys. Enjoy the rest of your evening. I will see you guys on Friday. Once the videos are ready as well, I'll share it with you guys. Thank you so much. Thank you, Matiba. Matimba. Yes, I think I got that right. Cheers, guys. See you guys Friday. Bye-bye.
Cheers, Gideon.
Cheers, guys. Thanks, Mashapa.